Welcome to EPG Pathshala. Digital System Design is one of the interesting module of the course Digital Electronics. Digital Electronics is the important branch of electronics. Digital systems are finding applications in variety of electronic gadgets. Digital systems has revolutionized and provided technological convergence in the field of science and technology. The applications of digital systems are computers, TV, home appliances, consumer products and medical instruments. In this module, you will learn about the basics of digital system design. After completing this module, you will be able to explain the importance of digital system design. In addition, you will be able to describe the digital system design approaches. Further, you will be able to understand the difference between fixed function ICs and programmable logic devices. Finally, you can compare fixed function ICs and programmable logic devices. This module is divided into 4 sections. In the introduction section, the importance of digital system design will be discussed. In the second section, different design approaches will be explored. There are two main approaches. The first one, standard or fixed function IC based approach, and the second one is the programmable IC based approach. In the third section, different digital system design approaches will be compared. And in the last section, we will summarize the important take home points. Let us now understand the basics of digital systems. Digital systems consist of 3 main parts: the system input, the digital system and the outputs. Digital system design is the science of organizing information, defining operations, accepting inputs and generating outputs using discrete qualities. Digital system can be either combinational or sequential circuit. Combinational circuit is basically the function of only present inputs and can be constructed using basic logic gates. Whereas the sequential circuit is designed mainly using the present inputs as well as the past inputs. It involves logic gates and memory elements. In addition, one can select technological options, that is TTL, ECL, CMOS, based on their relative advantages and disadvantages. In digital system, we mainly use digital ICs. ICs are classified according to the scale of integration, that is number of gates present in the IC. There are 4 major classes: SSI, MSI, LSI and VLSI. SSI is the small scale integration wherein the number of gates are around 1 to 30. The examples of the SSI are logic gates. MSI is a medium scale of integration where the number of gates are around 30 to 40. Examples of MSIs are decoder, counters and registers. LSI is a large scale integration where number of gates are around 300 to 300K. The examples of LSIs are small memories like RAM, ROM and programmable logic devices. VLSI is very large scale integration where the number of logic gates are around or greater than 1 million transistors. The examples of VLSIs are microprocessors, microcontrollers, memories, etc. Traditionally, the digital system design methods were based on scale of integration. These traditional methods of design are now challenged by recent digital devices called programmable logic devices, that is PLDs, which are based on LSI or VLSI circuits. The main aim of this module is to provide an overview of various design options that are available. The decision regarding the choice of design technique would depend upon several parameters like power requirements, size, cost, design complexity and frequency of operation. For designing the digital system for any application, the knowledge of various implementation technologies is essential. Let us now explore different design options available to the digital system designer. There are mainly two options available to the designer. Designer must decide whether to use available standard product ICs or application specific ICs from specific manufacturer. Thus, designer can select any one of the option depending on the application area. There are two types of standard product ICs available in the market. The fixed function ICs or processor ICs. The fixed function ICs provide a series of ICs with some logic functions like logic gates and or NAND, NOR, etc. Whereas one can go for programmable options in system design using microprocessors. In the market, the digital ICs are available from different logic families TTL, ECL, CMOS, etc. TTL stands for transistor logic, ECL stands for emitter coupled logic and CMOS stands for complementary metal oxide semiconductor logic. IC 74XX series is a standard TTL family. Under this family, we have different logic gates, adder, multiplexer, demultiplexer, encoder, decoder, counter, etc. IC's 7XXX family is a CMOS family having similar characteristics, whereas 10,000 series is treated to be the emitter coupled logic family ECL. Under processor options, we have three programmable approaches. Designer can select either microprocessor or a microcontroller or digital signal processing processor DSP processor depending upon the type of design. For high-end design applications, microprocessors are normally used. Microprocessor is a heart of every computer. Microcontrollers are normally recommended for low-cost application, whereas DSP processors are normally used for audio, video, multimedia processing applications. Traditional design approach utilized fixed function ICs and processors. The second digital system design option is to go for ASICs, that is application specific IC. This approach is nowadays replacing the traditional approach. There are two types of programmable design approaches. There are field programmable and mass programmable options. The field programmable ICs can be programmed in the laboratory, whereas mass programmable ICs are usually programmed by the manufacturer. There are 6 types of field programmable devices. These are popularly known as PLDs, that is programmable logic devices. It includes SPLD, that is simple programmable logic devices like ROM and RAM, and CPLDs and several other devices like PAL, PLA, GAL and FPGA. The mass programmable ICs are usually preferred when complex designs are to be implemented. Mass programmable ICs are categorized into 3 categories. First, gate array, standard cell and full custom IC. FPGA is a combination of field programmable option and gate arrays which are normally used in the design. This is a standard design approach which is usually called as a traditional design approach. In this system, the designer selects ICs from available standard functions logic families. For example, we have TTLs, ECL and CMOS logic families, and the designers have a choice to select one of them. Mostly the ICs those are selected are fixed function ICs. The examples are AND gate, OR gate, NAND gate, NOR gate and so on. You can have even the complex ICs like multiplexers, demultiplexers, encoders and decoders which are normally used in such design approach. Let us now discuss the advantages of traditional approach, that is fixed function ICs based design. The first advantage is shorter design cycle. The time required to design the system from concept to production is very short. The second advantage is that lower development cost. As the design is based on fixed function ICs, the development cost is low. And the third advantage is easier to test and troubleshoot. As a designer is involved in designing the complete product, it is easy to test and troubleshoot. Let us now study the disadvantages of traditional approach. The first disadvantage is larger space requirement. Fixed function ICs occupy a finite space in the total board area. The second disadvantage is the higher power requirements. As there are discrete components in this design, every IC would take finite power. The total power required is the sum of power consumption of each IC. The third disadvantage is hardwiring for interconnections. The complete design is based on discrete hardware. There are interconnections which are to be made hardwired. On the board like PCB, on such board modifications are difficult. The fourth disadvantage is the lesser reliability. The overall design involves many functional ICs along with separate interconnections, and the reliability of the interconnections is very low. The fifth disadvantage is lesser design flexibility. Due to complete hardwiring in the design, there is a less flexibility for the design. And last disadvantage is difficult to copyright. If one can carry out reverse engineering and trace the wiring diagram along with IC functionality, it is difficult to copyright. Traditional approach is nowadays getting replaced by programmable approach. Programmable approach is having two options. The first one, programmable logic devices or application specific ICs. Programmable logic devices are field programmable where user can program these ICs. whereas application specific ICs are mass programmable, which are normally programmed by the manufacturer. Let us now discuss the advantages of application specific ICs. There are 5 major advantages. The first one is the smaller space requirement. The programmable ICs normally provide single chip solution, hence the space required is smaller. The second advantage is lower power requirement. Single chip definitely has lower power consumption, therefore, overall power requirements are low. Third advantage is large volume production can bring the cost down. If this design is used in large volume production, the cost of product can be brought down. The fourth advantage is easier to copyright. One can copyright the design easily as it is a single chip solution. Major part of the design is soft wired, not hardwired. The last advantage is highest reliability. The interconnection density is very low. Therefore, this design offers highest reliability. Let us now discuss some of the disadvantages of application specific ICs. The first disadvantage is longer design and development cycle time. Usually ASICs are mass programmable, hence the design and development cycle is longer and takes more time. Second disadvantage is that design and development cost is high. As ASICs utilize specialized tools for the design and development, the total cost of production is higher. And last disadvantage is that special testing and verification tools are required. For all software based implementation, there is a need to have special testing and verification tools for different ASICs. Programmable logic devices are normally used to implement the digital systems, which is providing the advantage over the traditional fixed function IC based design. PLDs have advantages of both the approaches, fixed function ICs and application specific ICs. PLDs normally require both hardware as well as software while implementation. PLDs normally is user configurable and reprogrammable logic device, and user can program or change the program as per the requirements of the design. There are 7 major advantages of programmable logic devices. As the programming is done in the lab, the PLDs provide lower design and implementation cost. The single chip solution of PLDs occupy smaller space on the board. Hence, we have another advantage, that is smaller space requirement. Due to single chip solution, the power requirements are low. Hence, PLD provides the option and advantage of lower power design. As there are minimum interconnections on the board, the reliability of the design is high. The next advantage is that The PLD circuits are easier to test. Usually, simulations are carried out before programming. Therefore, it is easier to test. Single chip solutions can easily have a copyright for the design. That is why we always say the major advantage of PLD is you can copyright the design. And the last advantage, as PLDs are reprogrammable, reconfigurable, then there is more design flexibility as compared to other approaches. Let us now discuss the disadvantages of PLDs. If the design involves less product terms or some terms, then AND and OR array are not utilized to their full capacity. Therefore, we always say the disadvantage of PLD is inefficient use of logic devices and resources. The second disadvantage regarding the PLD is larger number of logic gates for implementation. PLDs provide all possible product terms using buffer and inverters at inputs, hence there are larger number of logic gates. Let us now compare the digital system design approaches. The first design approach that we have studied is fixed function ICs approach, and the second one is a programmable approach. Digital system implementations can either be fixed function ICs based or programmable ICs based. Digital systems based on fixed function ICs normally use basic logic gates and other complex functions such as adder, multiplexer, demultiplexers, encoder, decoders, comparators, counter, shift register, etc. Fixed function ICs are usually designed by the manufacturer for providing fixed functions, whereas programmable ICs are designed by the manufacturer such a way that user can easily configure and reutilize it. In order to compare digital system approaches, we will consider 11 different parameters. The first column lists all these important parameters, whereas the second column describes the characteristics of fixed function ICs and the third column describes the characteristics of programmable IC design approach. The first parameter of comparison is device density. Under fixed function ICs, the density of the devices is very low, whereas in programmable ICs, the device density is high, about 300 logic gates and further. The board space requirement for fixed function ICs is more, whereas in case of programmable approach, the size requirement is very small because all the circuits are part of a single IC. The power requirement of fixed function ICs is larger because it utilizes discrete components, whereas programmable approach utilizes a single chip solution. That is why the power requirement is also low. Normally for fixed function ICs, the development time is less, whereas in case of programmable ICs, the development time is more. As far as the development cost in a traditional approach is concerned, the cost is low, whereas for programmable ICs, we have to buy the general purpose programmable ICs where number of logic gates are fixed. Therefore, the development cost is also high. The logic testing required for fixed function ICs is very simple, whereas if you talk about programmable ICs, even the testing of the circuit and verification are easier. Let us now talk about the remaining 5 parameters in the comparison. The fixed function IC based approach provides less complex design, whereas programmable ICs approach provides more complexity. Fixed function ICs provide less design flexibility, whereas as we can program and change the design configuration, design flexibility is more. The time required for implementing the design using fixed function ICs is less. The same thing is true even for the programmable ICs. The security for the design is low in case of fixed function ICs, whereas the design security is more in programmable ICs based approach because it is a single chip solution. And the last important point for comparison is about whether the modification could be implemented or not. In fixed function ICs, providing modifications is very difficult, whereas changing the circuit configuration is easier. So, modifications are easier in programmable ICs. In recent years, there are major changes taking place in the digital system design. The systems are becoming more and more complex. The time required to market is very short, and the products are becoming cheaper and cheaper day by day. This requires computer aided design tools for implementation of digital system design. Usually, computer aided design tools are nowadays preferred over traditional design approaches. Let us now explore the real fixed function ICs that are commercially available in the market. If we talk about fixed function ICs, these fixed function ICs are available from least complex circuitry to the most complex circuit, which includes several logic ICs like logic gates, multiplexer demultiplexers, code converters, encoder decoders, adders, subtractors, comparators, flip flops, counters, shift registers, and so on. Let us now talk about different IC manufacturers in fixed function ICs. National Semiconductors, Signetics, ST Microelectronics. Intel normally provides microprocessors and other peripherals, and there are several other ICs, fixed function ICs available by Texas Instruments as well. The programmable logic devices like EEPROM, PAL, programmable array logic, programmable logical array, generic array logic, FPGA and CPLDs are provided by several manufacturers. These are ST Microelectronics, Texas Instruments, Xilinx, Lattice Semiconductors, etc. Let us now summarize the things that we have studied in this module. Digital system design using standard or fixed parts are quick to realize and relatively easy to debug. However, they are bulky and expensive when high volumes are required. Even they occupy more space on the board and power consumption is also high. The various programmable ICs are available that allow all sorts of digital systems to be implemented with minimum overheads and tools. Digital system design using ASICs or PLDs are most flexible options because there are very few constraints on how application specific logic is implemented.